Calculating probability when selecting more than one item requires us to multiply probabilities together. And if we are selecting only a few items, a tree diagram can be helpful. Suppose we are flipping a coin and then rolling a die. Here's a tree diagram to display the 12 equally likely outcomes. When the sample size is greater than 1, the word AND will imply that we multiply probabilities together. When n is only 1, the word AND will imply that we determine the probability of the intersection of two events, which has a lot more to consider. We'll get to that later. In our current scenario of observing two outcomes, that of both a coin and a die, the word AND implies that we multiply. Thus, the probability of getting tails and then a 3 is 1/2 times 1/6, which is 1/12. Hopefully you realize that all the outcomes of this tree are 1/2 times 1/6. Thus, all the probabilities are 1/12. Another key observation is that the sum of the probabilities of all outcomes equals 1. Suppose we wanted the probability of flipping tails and then rolling a number less than 3. We can convert the 6 simple events, simple outcomes and rolling a die, into 2 events and weight the branches of the tree with probability. In other words, the tree can look like this. We can now multiply our desired route through the tree of getting tails and a number less than 3. Our probability is 1/2 times 1/3, which is 1/6. Notice that the probability of flipping tails and then rolling a number that is not less than 3 is 1/2 times 2/3, which is 2/6. And if we add the possible outcomes involving getting tails in the first flip, the sum is 1/2. This should make sense because flipping tails initially accounts for exactly half of the likelihood of outcomes. Suppose there are 15 marbles in a bag. 8 are blue, 5 are red, and 2 are green. A marble is to be randomly selected, the color recorded, and then the marble returned to the bag. After mixing up the marbles some more, a marble is again to be selected and the color recorded. This is called sampling with replacement. By returning the first selected marble to the bag, it is possible for the same marble to be selected the second time. This preserves the original probabilities. Now find the probability of getting a green marble on both selections. The probability of green is 2/15 the first time and 2/15 the second time. We can translate the idea of getting 2 greens into a statement that uses the conjunction and implies that we multiply the probabilities together. Hence, 2/15 times 2/15 is only a 4 out of 225 chance of this happening. This means that if we selected 2 marbles with replacement 225 times, on average we would only witness 2 green marbles on 4 of those 225 occasions.